describe for me, if you will, if I'm a person and I say, wait a second, that all sounded pretty clear, except for when you said the phrase multi-omics data. You lost me. I don't know what that is.
Sure. So the omic sciences, and it seems like as a researcher in this field, every day there's a new omic that pops up, and they're usually related to some subset of the currently established omic sciences. And by omics, we're referring to the sciences that end in omic sciences, and those are the genome, genomics, investigating the proteome, proteomics. They are the complete set of their respective prefixes. So we talk about genomes, we talk about the complete set of DNA and genetic instructions within an organism or biological system. Same thing goes to proteome, all proteins, all post-translational modifications of those proteins, all isoforms, etc. We have the microbiome, which is the complete set of of microbes. And so these are the omic sciences. And when we talk about multi-omic testing, what we're talking about is essentially this concept of deep molecular fingerprinting, where we get data on a customer's genomics, transcriptomics, those are all the RNAs, the proteomics, the microbiome, as well as the metabolome. And that's where my focus really is as far as my own research career. I specialize in mass spectrometry-based metabolomics. Mass spectrometry-based means that I happen to mostly utilize mass spectrometry, although I have some tangential experience with other platforms. We mostly utilize mass spectrometry for the sensitive and specific detection of your metabolome, which is, again, your complete set of metabolites, the end products of your metabolism. And so they are the end products of all the biochemical processes that happen within you, and advances and drawbacks. And there's pros and cons to every level of systems biology. But when we tie them together and we integrate these levels for an individual, what we get is a deep molecular fingerprint, which is a multi-omic assessment. We use more than one level of an omic science. And by doing that, we sort of mitigate all the shortcomings that are inherent in any individual level of omic sciences, because whatever shortcomings the genome has in analyzing the genome, the metabolome largely and the levels downstream largely mitigate. And by doing this, we create the most comprehensive, by that I mean it's really hard to imagine how you could assess a human being's biology any further. If you have all levels of these biology and you just start growing the panels, and we get this incredible coverage of human health when you compare it to what's traditionally measured using a multifaceted array of diagnostic techniques, complete blood counts, or organic amino acids test, lipid panel, et cetera. Then you have the imaging techniques and everything that goes on top of it. We're proposing is a true multi-omic shift in how we assess people's health. And by layering this data, we can not only give them more specific, tailored recommendations and usher in this new era of personalized medicine. How do we achieve that personalization? It's through this deep phenotyping. And then what we do is we use our data, we analyze it, and we leverage it for continued scientific discovery and insight. So not only can it be used for an immediate vertical advancement of patient care that we can realize today, but throughout time, this sort of data will lend to changes in how we investigate potential causal mechanisms. It will inform funding mechanisms on what types of research on what topics should be prioritized. And we will become a more directed and efficient research enterprise as a whole, community of scientists.
Yeah.